All right, welcome back, everyone. I hope you're having an amazing time so far. I'm excited to introduce our next panel, the state of AI in supply chains. Please join me in welcoming our panelists to the virtual stage. And I'll hand it over to Danny, our moderator.
Thanks, Patricia. Appreciate it. Hi, everybody. My name's Danny Siegel. I lead a group called Information Delivery at Newell Brands, makers of everything, many brands I'm sure you're familiar with, from Sharpie to Graco to Papermate to so many, too many to name, frankly. Our team is focused very much on everything data related, from data ingestion, pipeline creation, all of the platforms, data warehouses, as well as the AI and ML technology that supports our various data science teams globally. And of course, one of our earliest and richest applications of that technology is in the supply chain space, which we'll talk more about today. So I'm going to start with some introductions around the horn here. I'll go to my right with Gregory Brown.
Hello, my name is Gregory Brown. I work for UPS, head up the Advanced Technology Group at UPS. That group is really developing solutions for our global smart logistics network. And I work on things like robotics, autonomous vehicles, drones, and then sensors and IoT. Thanks for inviting me to the panel.
Thanks, Gregory. Next to Gregory, I have Franziskos.
Yes, hi, my name is Franziskos Kyriakopoulos. Thanks for having me. I'm the CEO and founder of 7LYTIX. 7LYTIX is a company from Austria in Europe. We do applied artificial intelligence for supply chain, retail, and industry. And we have a software as a service where we have mapped the important use cases in this area, like demand forecasting, replenishment, product recommendation, anomaly detection. And this is what we deliver to our customers, which are mid-sized and large corporations in Europe, like Deutsche Bahn, for example, retailers, industrial companies.
Thanks so much, Franziskos. And Aleksandar.
Hi everyone. My name is Aleksandar. Thank you for inviting me to the panel. It's my honor to be here. I'm a VP of Advanced Analytics and Data Engineering at Stanley. I'm leading a centralized analytics organization focusing on various analytics use cases, ranging from demand forecasting and inventory optimization to pricing, customer experience, e-commerce. For people who are not familiar with Stanley Black & Decker, similar to Danny, we involve many more brands than just our name stands. We also have many more businesses than just the tools. We have security business, healthcare, fastening and rivets, oil and gas pipeline, aerospace manufacturing, just to name a few. And we provide a quite range of products and services to our customers.
Very good. Thanks for the intros, guys. And I think what we're going to do here is flash up some questions that we'll send around the horn. Patricia, if you wouldn't mind putting the first one up, there we go. So the first question here being, supply chains and AI, is it a perfect match or a breakup waiting to happen? It'll be a very short conversation if it were the latter. So I think maybe I'll jump in and give my perspective, and I'll ask the other gentlemen up here to jump in as they see fit. I think it's actually because supply chains tend to be highly instrumented things to begin with, at least for Newell, and I can say for other companies I've worked with, it's a very rich area for analytics. A lot of consistency in the way data is captured, and a lot of money spent, frankly, and purely in the cost line of most P&Ls on getting our products manufactured and getting them to customers, and of course, getting raw materials brought in. So not just, I would say, an available space to perform more analytics, but a rich place for even more. And from a Newell perspective, we're certainly going further and faster in that direction in so many ways. I probably couldn't touch on them all. Anyone else have a similar perspective or different perspective?
I can chime in. I definitely agree. I think considering the fact that supply chain includes many entities, really ranging from customers, retailers, warehouses, distributors, manufacturers, suppliers, just to name a few, I think there are multiple of topics we can really capture with overall supply chain and how AI can help, starting from designing a new products and services, procuring raw material, manufacturing them, optimizing that whole process. In that overall circle of the supply chain, really, as I mentioned, there are multiple opportunities. For example, how to understand the customer needs, what customers like, what they dislike, not only from our product, but from competitors, how we can incorporate this information into our production, how to properly predict the demand from retailers, but also from the end customers as well, how to optimize our inventories, what the optimal level of the safety stock, is that important right now, how to optimize your freight logistics. I believe Greg mentioned also self-driving cars as well. I think these are some aspect that we can definitely include. So in my opinion, if we are not maybe as a perfect match yet, I think certainly AI and supply chain going into that direction. I think in that overall kind of process, we can start trying to leverage not only our internal data that persists within our companies, but plethora of external data as well. And I'll be happy to talk more about that later. But my opinion, AI has a perfect opportunity to help organizations not only survive, but actually win over their competition as well.
Totally agree with you, Aleksandar. Gregory, Franziskos, you want to jump in here?
Yeah, I'll chime in. I would say that as it relates to AI and supply chain, nothing is perfect. I mean, but the bottom line is, if you're not leveraging AI and data to make decisions in your supply chain, you're going to be left behind.
Yeah.
Part of the reason is that the customer behavior has changed. Many customers are looking for their products to come sooner than later. They want to be able to change their process. They leverage their mobile phones and PCs and things of this nature to order and request and really make adjustments and changes to the things they order quickly. The return process, the whole infrastructure of the supply chain has to be able to adapt to the customer. And quite frankly, it's much more complicated than it was in the past. So if you're not leveraging AI, you really won't be able to meet the needs of your customer. And then you can apply the AI and techniques that are available that fit now. And then as you get better data and you have more equipment that is leveraging data over time, it gets better. But definitely you need AI to meet the needs of your customer.
I agree with you, Greg. And it's getting difficult and impossible to avoid, but it's also getting easier because there's so many more quality data capture points as inputs to some of these approaches to optimizing supply chain processes. Sorry, Franziskos.
Yeah, so I think there is a big vision, and the big vision is the one of autonomous supply chain. Yeah. Yes, and AI will be a key player of autonomy. If we think about reinforcement learning, in a perfect world, then all these micro decisions that you have to take in production, in replenishment, in retail, in purchasing, and so on, in planning, will be taken by agents. So this is where we want to come to some point, so we can just monitor the systems and drink coffee. But we're not there, clearly. And there, I mean, the States or Asian countries are far more digitalized and advanced than European countries, I would say, in this aspect. What we see here in Central Europe is still that we are in a state where some data are in Excel and they're brought together and updated manually. I don't know how this is in New York, but I would assume a little bit better. So we have a long way to go, and it's a difficult relationship. And as Gregory also mentioned correctly, it's one which gets more complex as we want to go to this optimum, because you get more sensors, IoT, so you have more data, you need to put all of this together, then you have more influences, and of course you have shocks like COVID-19, which can either bring your whole supply chain up by 50% if you're in the correct sector, or bring you completely down if you are in fashion retail, for example. Yes, so it's very interesting, I would say.
Thanks, Franziskos. And I'll say, I mean, I don't want to speak for my colleagues here, Gregory and Aleksandar, but from the state's perspective, no, we have as many spreadsheets as you could possibly imagine. It hasn't gotten any better. So I don't know that the ocean between us has improved that. I think, Patrick, if you could jump to the next question, we can kind of keep going here and further the conversation a bit. So advantages that AI provides to supply chain management. I think I'll follow up on this one and defer to my colleagues here to start us off. Anybody want to carry this ball?
I don't know. Yeah, go ahead.
I'll start. I'll say that one of the advantages that AI provides, it allows you to do things like fleet management or optimization. So at UPS, we leverage a technique, or really we have a software package called Orion that allows us to plan our driver's day. And what that does for us, it allows us to get as much as we can out of our asset in terms of the package car, filling the package car, and then moving the package car through the delivery process. And then also just in terms of replenishment within the network, that package car coming back, picking up more packages. So that's one example. And I think that if you don't have things like Orion, for like we have at UPS, then you really won't be able to really maximize those things, the transportation and other aspects of your network. And also within your facilities and operations, if you can leverage various techniques that allows you to optimize the usage maximize the usage of your warehouse or your facility, so that you can have an optimal process that allows you to really save money and get as much out of your warehouse as well. So AI can be very effective in both applications.
I think that makes sense. Aleksandar, Franziskos?
Yeah, I absolutely agree with Greg. I believe that traditional methods that are used in supply chain right now are simply not well suited to capture some of the complexities in this space. And as Greg mentioned, actually, these complexities are getting worse and worse. Even before COVID-19, we started to experience, erratic demand coming from retailers or from customers, a lot of changes because of our competition, because of other things, really. And traditional methods simply cannot capture all of this. So that's basically the major advantage, in my opinion, of using AI and machine learning. And I believe Francisco mentions ability to automatically predict, or at least that grand vision to go towards automatically prediction of behavior of large portfolios, removing human bias, using some form of statistics or machine learning to predict something that is inherently statistics in the nature. Also, AI has become already dominant in demand forecasting world, allowing companies to develop deep insights, what is driving their sales and what their sales will look like in the future, by trying to discover things like finding what are the leading sales indicators, factoring in different kind of sales and acquisition or mergers, major market events like COVID-19, not necessarily to predict them, but to incorporate how this would affect your sales. Also, you can improve the demand forecasting by including multiple variables and external information, something simply that humans and traditional methods cannot handle easily. And also, I already mentioned the plethora of internal and external data that is really helping this overall the process. From internal perspective, you can leverage a lot of point of sales data, promotional data that you as a company run, historical demands, inventories, but there are also a lot of external data, actually more and more these days, that includes how to capture customer trends, how to understand the customer reviews, how to understand certain seasonality effects or trends, even competitor data, what competitors are introducing, how that would affect your sales, your revenue, retail's promotion, very important financial economic indicators, because that significantly affect your demand and your sales in general. And finally, in the supplier world, I think a lot of firmographics data, a lot of companies offering this kind of data as well. So all of these factors really contribute to actually having AI and machine learning playing a really major role in overall supply chain.
Yeah, I think that sums it up really well, Aleksandar. I was just going to say, I think one of the primary advantages AI has over what I would call kind of classic optimization techniques, linear program or what have you, that have been around for eons to make supply chains more efficient is they're capturing the both the non-obvious relationships between variables, and of course you can bring in factors that and identify factors that perhaps no human would have expected had a real impact on the efficacy of a supply chain, but it turns out have some real influence. And to test that and hypothesize, and frankly to fail very quickly and cheaply, and to come up with you know, a stable set of variables that have high predictive value that any one person sitting at their desk who is brilliant would never have come up with. So that's one of the primary things I see about AI as being so useful in supply chains. Sorry, Franziskos, I didn't mean to jump in the middle there.
No problem, fine. So I can only agree. The main driver, what we see now that is in applied AI in logistics, is demand forecasting. Why? Because people start from an ERP system, which maybe have some rule-based forecasts or some very simple models like moving averages and Cronstow's methods and stuff like that. And they see that this does not work out, or even better, the forecast is just expert-based or comes from salespeople, yes, and they see that this does not work because no human can in his mind quantitatively evaluate all these factors that play and deal with uncertainty, and our brains are not made for non-linear stuff, yes. So what we see is that if you use some advanced methods like hierarchical forecasting, deep learning neural networks, or boosted decision trees, which work quite well, and put the right data in, then you will have a much higher predictive accuracy. This is one main driver. The second is was already mentioned. I want to give you an example. This explainable AI trend is that people want to know what drives the sales, which of the factors are how important. And what we see is that we are confronted with some dogmata. When we talk to our customers, they say, well, we know that our sales correlate with the automobile industry raise, or with some producing manufacturing indices, and they think that this will be the case for all their markets and all their customers. And what you can show quantitatively is that yes, in some cases it is the case, but in other countries where you sell your products, it's not. There are other factors there that come into play, and this shocks people a little bit, because you know, everyone who has a dogma in his mind and then gets counterintuitive insight is needs to deal with this, but it works at some point, yes. So they start opening up and saying, okay, we'll take this into account. These are the two main things. And what is very important also is that you can have a very good forecast, but if the forecast tells you that your trend is going down, then you also have the ability to change that. For example, with recommendation engines, which is again an AI method, yes, because you can bring your customers to buy other products or use dynamic pricing to incentivize a different demand, and then you are actually changing your own prediction to the better, hopefully.
Yeah, I think that's great input, and I think great insight. The interesting thing I was also thinking is one of the key advantages, at least I've seen, is it gives a multiplicative factor to the human intervention in supply chains. So supply chains that are managed exclusively kind of handheld by humans have the costs are quite fixed, but they grow linearly with the size of your supply chain. You have to add more people to manage it. AI, of course, makes people, like a planner, as you were just describing, Franziskos, if I can get a recommendation for the 100 materials I have to demand plan, and 95 of them have a very reasonable predictive rate based on the model, and I can simply accept those forecasts or demand plans as the way we're going to go to market. And the only ones I really have to think about, because of some things the machine simply might not know, that's a huge time saver and actually a big contributor to kind of efficiency in the supply chain. So good stuff.
agree. Can I just add something?
Yeah, of course.
The comments on demand forecasting. I absolutely agree with you. There are more and more complex situations. In our particular case, actually, we have a lot of intermittent demand, some demand for some new products that simply could not be handled by just human nature. Really, if you apply some of the advanced analytics, trying to find similar products where this kind of historical data could be relevant, you can achieve a lot. And also, coming to your comment regarding that, when you talk to business partners or client, they discover that some of their sales are correlated with something else. And I would like to basically point to the fact that actually this may be true, but they need also to understand that it's not a causal relationship.
Mhm.
It may be that correlates, but they need to understand what is causing their sales to do something. It's maybe the other way around, and they don't care about this in this case. So I think breaking this kind of the tribal knowledge is extremely difficult and challenging in many situations.
Totally agree. Yeah, there's a change management in the people around AI and ML applications supply chain just as much as there is work on the data science side. So
absolutely,
that's important stuff. Why don't we, in the interest of time and just to keep it flowing here, jump to the next question, Patrika, if you wouldn't mind putting it on the screen here. So challenges that the four of us might face using AI in supply chain. I think, it's funny, at least from a Newell perspective, and I could probably go on for another 30 minutes about this, so I'll keep it brief. I think one of the challenges that we've seen with using kind of the advanced analytic techniques is that with the advent of the technology, the data probably hasn't had as much of a focus, at least in our company, as it does now, because we see it as being an important input. So we have to spend a lot of time and energy getting the data just so that the machine can run with it, and having to prepare it. That's sort of that important separation between data engineering and data science, if you will, where the data scientist sits down and probably spends, I don't know, 2/3 of their time conditioning data and only 1/3 of their time actually doing the valuable work of the data science to come up with an insight, is a challenge that we faced, and we're working hard to overcome it every time we run into it. But it's kind of it's 2 steps forward, 1 step back for us.
Yeah, I absolutely agree with that. I mean, for our case, Stanley Black & Decker is not traditionally a data-driven company. I mean, they collected the data mostly from the legal perspective to record some sales, but not from the perspective to use this data in analytics, really. So data quality, speed, how we get this data, aggregating all these different legacy systems is extreme challenge. Just to give you a notion of how complex this is in our case, we have more than 75 different ERP systems that are capturing different regions and different brands. So just imagine the pain that we actually face when you have
Alexander, if there were a medal for number of ERP systems, you won.
Okay, so can you imagine the pain, when you try to aggregate all this information?
I can. Yeah.
And that's why we are sometimes even focusing on the high volume or something that we can just try to make some business impact. The second challenge, in my opinion, in addition to data, is definitely the business itself, their openness to applying analytics. This is traditional field when traditional methods were used for years, really for 30, 40 years, and people are already used to this. And as you mentioned earlier, that kind of change in management is really kind of a problem here. People have to be open. And the significant portion of that openness is lack of understanding what AI, data analytics, or machine learning means, and how this will help the business. People often believe that if they start using AI and machine learning, they will lose the job, or they will eliminate some people, there will be layoffs. How we typically approach this, we try to share, your job would be much easier. You would be able to sit and monitor a system, and Francisco was mentioning earlier, instead of just doing everything yourself. And that's how we try to present. Basically, they will be more efficient, they will be able to create more impact for the company. But in my opinion, that change management is really critical for success of machine learning, data analytics in general in supply chain. I think that's really, really, really critical that many organizations are really overlooking at this point.
Aspect is probably wildly undervalued. I agree.
So I'll chime in here as well. I think there are a number of challenges when you leverage AI in your supply chain. So UPS has been around a long time. So we have a number of older facilities or processes. And I would say part of the challenge is the infrastructure cost to convert everything over. Or if we want to add mechanisms that collect data and generate data, the cost of adding that to your process. And then there's the data quality, cleaning the data, preparing the data. Because if you think about a network that's been around, we're certainly making the necessary changes, but the process of converting your network over, turn it into mechanisms that collect the data. That takes time. It takes costs. You need compute power. So then you have to kind of think about, do I leverage the cloud? If I go to the cloud, do I make it a public network where my data is exposed? So that whole process of getting to the point where you, one, generating the data, cleaning the data, changing your infrastructure around, and then two, taking your algorithms that you're developing and really moving them forward to the point where they're maintained over time as you get new learnings in, the maintenance behind it. The other side too is that if people are around you that are leveraging these techniques, they don't really understand how the systems work, how the algorithms work. There's an ROI piece of this as well, where you have to kind of define, here's the benefit you're going to get. We don't have it yet, you're going to get it. Or here's why you need to use this algorithm. Being able to articulate at times what the real benefit's going to be before you get there can be a challenge as well. I think there's a number of challenges. So there definitely, the benefits are there, but as we continue to transition to meet the needs of the customer, it's something you need to do, because if you don't do it, again, I'll say you're going to be left behind. You have to kind of make that transition. Some people call it industry 4.0, where you get rid of paper, you convert and you digitize. I think that's that process that you go through to get there enables you to do more with data and develop the algorithms that are needed.
It's an interesting perspective, and one thing I was just thinking that kind of jumped to my mind when you're speaking, like, we're also crossing that transom of, I think all four of us would agree, we're building data science competency and building up those models and so forth. But just as fast as we're building the skills to make more models, industry is making it as a service. So in some sense, even AI ML is becoming a build versus buy kind of decision, and supply chain, because of its nature and because it was probably one of the origins of a lot of the early thinking in optimization and using kind of sort of the nonlinear techniques to advance it, then they have a ton of offerings. Just about everything we've spoken about, one of the big supply chain cloud providers is willing to sell it back to us. So it's sort of it's a quickly evolving marketplace, and it might be worth handing the problem to somebody else. It's a very mature problem, and we talked about demand planning. How about we're all talking about demand planning, but there's a lot of people who offer it as a service now. Is it worth continuing to model? I don't know. I think it is for now, but not for long.
Yeah.
Franziskos, have you seen anything in that direction?
Yeah, well, the thing is that AI as a whole, not only in supply chain, is exponentially growing, a little bit like COVID in the bad times. So you have so many new papers per day coming out from top researchers all over the world. So if you're in the AI business, you need to keep track of that. Yeah, our field is changing so fast, and at the same time, if you have so much new methods and models and algorithms, nobody can assure how good the quality of each of those is. Less in a specialized use case like demand forecasting, etc. So this is a challenge to keep track with what's coming up. Yeah. Another challenge, which is quite interesting thing, is the statistics of supply chain, because intermittent demand was mentioned already. That means that for most of your products, the number of sales per day or per week is 0. Yeah. So if you train your neural network, which can be a fancy one and deep and what do I know, and most of the time it learns zero, then you will have a hard time predicting accurately when something happens. Yeah, you need to find the day where this product is getting shipped. So this is a highly statistical challenge, because it's a so-called, it's a Pareto-like fat tail distribution, and some statisticians like Nassim Taleb argue that in such a case you shouldn't even make a point forecast. Yes, I don't completely agree with that, because this is our business, this is what we need to do. I cannot tell a supply chain manager, well, here is a probability distribution about the goods you're going to service. I need to tell them, or the software needs to tell them, you will have to deliver 3 SKUs from A to B. Yeah, you need to give a concrete answer. So this is a challenge. And then there is the cultural challenge of, and by culture I mean data scientists on the one side and business people on the other side, which need to speak the same language, which they don't, because you have, I don't know, physicists, mathematicians, informatics, computer scientists on the one, and you have business people on the other, and they don't always understand each other. And this can cause some problems.
Yeah, very true. Can I just add to something to that? So that's very true. I experienced this myself within our organization, in previous companies that I work. And that's why this kind of new roles, data translator or data storyteller, emerge as people who can understand or speak maybe both worlds. But yeah, I believe it's extremely important on data scientists to learn more about the business, to have a proper understanding what's driving the business, what's driving the complexities, but also on the other side of the business to understand a little bit more on data science, at least to expect what is the art of possible analytics side, whether it's like a silver bullet that can solve everything, or I don't trust analytics at all. So I think that's kind of middle ground should exist. And sometimes organization go and use a product managers or analytics translator to bridge that gap, but it's definitely a challenge that I see on a daily basis. I also want to mention something that Gregory talked earlier about, the challenges about the using the right environment. What I also observe here that sometimes people, when believe they can run some analytics, they go download the data on their laptop and start doing something without realizing that they compromise the data integrity, but also very quickly they will realize they cannot run anything on the laptop because of the huge volume of the data they have to analyze. So that's something we need to bring to the awareness people, that that huge volume of the data will require a different kind of environment that people need to use in order to run analytics and properly make decisions.
Yeah, totally agree, Aleksandar. That's a battle we've been fighting all along. And I think well, actually, no, you mentioned it with the spreadsheets being, no, as Franziskos mentioned, the spreadsheets being kind of pervasive means of performing analytics. By their very nature, they have low limitations in terms of how much you can actually do on it. So we run into it all the time where people hit the ceiling on that and have to move to a more advanced platform. So this is a great discussion. Let's jump. We have only a couple more questions and about 15 minutes, so let's keep going here. COVID disruptions. This is a very interesting topic. And how has COVID disrupted organization supply chain? Did AI help or hurt in this shift, and how? I won't divulge too much other than to say that AI models didn't predict COVID. So there's only so there was only so much they could do. But they also couldn't predict what would happen when people couldn't unload ships, for example, right? So I saw a map just the other day. We have thousands and thousands of containers coming across ships, mostly to the west coast of the US, but the number of ships sitting parked out in the ocean because they simply can't come unload their goods. Well, that's stuff that a very sophisticated AI algorithm had anticipated would be available in a warehouse to ship, and it isn't there. So the feedback is getting very noisy at the moment. I think that was one thing that COVID kind of created, that it sort of skewed the output of the models. That it's not a predictable thing. Let's be clear. I just read the other day that AI, as used as a tool for diagnosing COVID, is also terribly flawed. So I'll ask my colleagues here to jump in.
Yeah, that's very true. Actually, you're very right. I read actually several studies around, how even pandemic and the number of cases of deaths could be predicted. There were a number of machine learning models that trying to do this,
Yeah.
but it was extremely challenging, really, because there are many things, many regions, many different policies per state, per country, all these kind of things. This was extremely challenging beast to try to model. And we experienced similar things. We tried to do the similar things at the beginning of pandemic, but we actually gave up, considering all the complexities. Going back to the question, how COVID disrupted our organization, I think it disrupted it significantly. At first, our manufacturing was affected. Many companies stopped working, so that access to workforce was really impacted. Second, the customer demand was certainly not known, because people stopped their life literally in March and April last year. Everything stopped literally, and actually customer demand dropped almost to zero. And actually, how to predict what will happen in the next few months, that was really significant challenge for us. Also, supplier risk. Many suppliers, especially low or middle suppliers, were actually facing going to default or to bankruptcy because they didn't have enough work. Also, freight logistics were significantly affected. Many carriers were, as you mentioned, were sitting in the port, or they were fighting, many trucks did not drive. All of this really contributed to uncertainties that we have. And finally, the entire COVID situations affected the whole thing. So we basically started to track the COVID number just to see where there would be certain improvements and whether we can try to reopen some of the factories in certain regions, depending on the number of cases, depending on the number of, improvements and stuff like that. People were trying to implement some of the social distancing. We include some kind of sensors to track the people. They are maintaining the social distancing while being at the factories. So these are some of the metrics that we try to use as well. And also in demand forecasting work, we try to not rely completely on just historical internal data, because they would be completely useless because there was completely unprecedented event. We try to leverage some financial and economic indicators, COVID numbers, even some weather to predict and see how we can predict the demand. And actually that worked relatively well, considering that, typically what's happening in the economy followed what's happening in the stock in the market. And that worked relatively well for us. We were able to predict relatively well our demand. So that's basically what we did.
That's impressive. I'm sure our respective companies had a lot of the same challenges. Gregory, I'm sure from a UPS perspective, with so many people at home now unwilling to leave their homes and basically ordering everything they eat, they clothe themselves with, whatever, online, it must have been a unique challenge for you guys.
Yeah, no, I would say that it created a unique problem for UPS. Typically, we have our peak season at the end of the year around Christmas.
Right.
And from March onward, it really put UPS into a peak mode. We had more volume flowing through our facilities. Our package car drivers had to kind of deliver more packages to the home. Going into COVID-19 or the pandemic situation, we were already kind of looking at future impacts from e-commerce. The e-commerce boom is always something you're looking at, and really COVID-19 turned that on. So it really brought that e-commerce boom sooner than many people were ready for. And I think UPS adapted. Everyone really is adapting and has adapted. But the big thing for us, it put us into a peak mode sooner than we wanted.
Was it, out of curiosity, Gregory, were you're like any of the kind of classic productionalized models you had sitting out there that were kind of routinely forecasting some simple stuff, they were just thrown out temporarily because they simply didn't work anymore in the COVID context?
Yeah, basically, we had to kind of, we basically went to our peak plan. Right? Yeah. We're used to dealing with peak every year. So what you do is you switch to that operating model.
I gotcha.
And so we had at least that to fall back on. So that's what we did.
Makes sense. Makes sense. Franziskos?
Yeah, so what we saw with COVID was that, of course, on a long-term base, the models failed. But this is, I would say, not a problem of AI. It was a human problem because nobody anticipated this and tried to make models that take into account some facts and some news and say, hey, what's the probability that a shock like this or a pandemic will come out? I mean, this is not the first pandemic that has come out in human history. Yeah. And if you think so, to give a concrete example, in January 2020, there was a paper published by some physicists and complexity scientists with recommendations to the US and other governments where they said, hey, guys, something coming up here, you should try to do some measures and enforce some measures, and which of course was completely ignored with the consequences that we all know. At that point already, or in February, when we're in Italy, for example, you had rising levels and you can collect data, there would be the option to have a model that at least it doesn't tell you how much your sales are going to drop, but it tells you that you have a high risk of something happening here. This could be possible. So this is also a failure of people being alert, yes, and looking what can happen.
Franziskos, you say, I'm interested though, because now that we have some history built up during a pandemic period, do you see are models sophisticated? I mean, it begs the question, but do you think models are sophisticated enough now to interpret the data that we've gotten over the last year and say, okay, I know what the initial point of a pandemic starting to occur looks like. Therefore, if it happens again, the machine has some sort of knowledge, some sort of weightings, and I'm thinking in context of a neural network, but there's 100 approaches that would work where the weightings would suggest that something's happening.
I think the models are sophisticated enough. It's not like you need something that we don't have. It's either a classification or a regression problem. I think the most important challenge is to be aware where your data sources can be. I read somewhere that already in December 19, some guy in the US had made a website collecting data about Wuhan cases and infections, and he had a dashboard in December. Yeah, so this guy was smart because he was collecting the data at that point, and if he would have built a model and he would have the power to inform someone who has the power to take decisions, maybe some lives would have been saved. Yes, so it's. Again, I don't think it's a matter of sophistication or of the algorithms. It's a matter of scope, that we are alert that these things can happen, and some other epidemic can or pandemic can come around. And now I think we are. So there has been put a lot of effort and a lot of money now into making some initiatives like that. So alone, I don't know in the US, but in Austria, we had several calls for grants for research institutions to build early warning systems. Yes, and I think, I mean, we also have banks. We're in the financial sector also. We make early warning systems for credit default with 1 year in advance. You can do something like this here also. Yeah,
makes perfect sense.
On the short term, I think the models did not fail so much, because what we saw is, of course, if you have a hard lockdown, which you don't anticipate, then you have maximal error in your forecast. This is true. Yeah, it goes from 100 to 0%. But in industries like supermarkets and supply chains, like frozen foods, for example, which we tracked, there you had a short upraise. In Austria, it was in March 2020, like they went 50 to 80% more goods delivered. Yes, the model failed that initially because it didn't know anything about the lockdown and the ramifications. But after 1-2 weeks with online learning and retraining, you can catch up with that.
Yeah, we actually seen a similar kind of trend here in US. We actually follow some of the customer demand data, and we definitely seen a spike in March and April for not necessarily consumer goods, but also for our products. I believe that people figure out, since they will be locked at home for several months, they said, okay, we have to do something at home. This kind of do-it-yourself project was sitting for a few years. It's time to finish that. I think we have a record Q3 and Q4 coming out of these kind of activities from people.
This is, I think, a common theme around at least the consumer products businesses that we're in as well.
Yep.
So let's do this, guys. We have one more question. We'll use this as it's a fairly general question. Patrick is going to post here. How will AI transform supply chain over the next 5 years? So this is our parting shot question. I think I would say it is, from my perspective, it seems to be making supply chains dramatically more efficient, more adaptable, and kind of more inexpensive. So I think we're going to see supply chains with AI being applied in more and more areas within supply chain. We'll see costs come out, profitability improve at levels that probably haven't been seen, but for the last 20 years using the same technologies. It's advancing so quickly, not just the application of the techniques, but the compute power, the collection of data, and the focus that industries have on the use of the technology. It's going to flourish, in my opinion. Gregory, I'll let you give your last shot here.
Yeah, so I'll say that for me, I think that as we start to look over the next 5 years, people are already starting to be okay with having more technology in their homes that really collects data. So I think that you're going to see more and more of this data being leveraged across the supply chain, so that you can, have the touch points to make the supply chain simpler and easier or more convenient. Because as customers start to change behavior and they're okay with having their data being exposed, now people that are bringing goods to that home can leverage that data to marry up with that convenience, therefore making it easier for us to kind of move goods. And one thing I was thinking about is that when you think about the future, we're definitely going to have autonomous vehicles. You're going to have, and even if you don't have autonomous vehicles, people are more apt to put things onto their vehicles to track. At UPS, we're making our packages smart by putting RFID on the packages, so that you can now sense and know where the packages are. So if you know where the packages are, you know where the vehicles are going, and you're more connected to the home, then that whole supply chain becomes a little bit more seamless, because you have the infrastructure to align up with customer behavior.
Fascinating. It's good stuff, Gregory. Franziskos?
Yeah, I also think that in the next years, it will be the digitalization of the whole process, which will be the main driver. You will have more and more sensors everywhere, hence more and more data. And then we can fill this black box, which still is now. And also digitalization, we talked about spreadsheets. This is also a move which will hopefully will become better, that people at least use a database and instead of a sheet, and I hope that we will learn to understand each other better also with this business versus data science stuff, because it's if it gets more repetitive and if you hear the same stuff again and again, then at some point you may learn to perform it, and change management will be also here quite important.
Thanks, Franziskos. Totally agree. Aleksandar?
Yeah, I definitely agree with all of you guys. I believe many companies will still feel the pressure of optimizing their overall supply chains, cutting the cost. I agree with you, Danny, that there will be focus on more automated in the system, more optimization, more using AI and machine learning. I think the overall journey that was just accelerated through pandemic will continue. That kind of digital revolution will continue. I believe that the developing of advanced understanding of how to leverage machine learning and AI would be really key, as well as understanding the key driving business factors. And I think that would be putting you ahead of competition. I believe the famous demand forecasting person, Paul Safa, said the goal of demand forecasting is not to predict the future, but to provide you what you need to know in order to make meaningful actions right now. So I believe that's what we need to do. And I believe AI and machine learning is not nice to have functionality anymore. It's, I believe, the necessary thing for companies to survive.
Thanks, Alexander, and thanks everybody. Great engaging conversation, gentlemen. I appreciate it. Thank you, AI Forum, Patrika, for the opportunity to do this, and I'll hand it back to you to close us out.
Wow, thank you. Thank you so much to all of our panelists. This has been an incredible conversation, and a special thank you to Danny for moderating and keeping us in line. This has been awesome, and I know the audience is giving you a huge virtual round of applause. All right, for the audience, it's time for you to make your way to your next session. Along the way, make sure you accept your connection request and check out our amazing AI exhibits. Thanks so much, and we'll see you around.